Alright, so we were finishing up this example that we started last time. And so we're given our two differential equations here. And for the method of the Nullclines, we set each of the functions equal to 0. And we try to see, we graph these Nullclines first, and then we try to figure out which direction they're traveling. So initially we started with the two curves for which x prime equals 0. And so if x prime is equal to 0, that means you're traveling only up or down. And so the direction of travel then is going to be determined by your y prime in each of those cases. So now we're going to flip the situation and say we're going to look at the cases where y prime is equal to 0, and then we're going to see if we're traveling left or right. Okay, so we look at y equals 0, and in that case the other equation is going to be x times 2 minus x equals 0. And so we want to determine, that's easy enough to kind of figure out just by looking at the parabola here, right? Because it goes through, the parabola goes through 0 and 2, and it's an upside down parabola. So therefore we're going to be negative, positive, negative, right? And so that means if x is less than 0, then we're going to be traveling to the left. And then if x is between 0 and 1, we'll be traveling to the right. And if x is bigger than 1, we'll be traveling to the left. So let's put those items on our graph. Okay, so that is the, let's see, y equals 0 graph. And so that's the purple line that you see there. So if x is less than 0, then we're traveling left. And then here we're traveling right. And then here's where x is equal to 1. And so there is a change right there, right? On the other side will be, let me check my graph here real quick. Okay, so that was a 2, not a 1 here, so the change is here. And so this would continue on. And then on this side we already drew in the line there. Okay, good. And so already at this equilibrium solution we can kind of see what's happening, right? We have two solutions that are heading in, and then the rest of them are kind of going out this direction. So what do you think is going to be there? Did you say saddle? Yep, that's going to be a saddle. Okay, so of course we could verify that later, but that's just a little bit of information that we could get. So finally our last one, let's see, we've got x equals 0, 2 minus x, y equals 0. So now we go for y equals 3 minus 2x. And so what's the other curve in that case? Well, our x prime is equal to x times 2 minus x minus 3 minus 2x. I'm substituting in for y. And so we set that equal to 0. And so if we simplify that, what do we get? 2 minus 3, b minus 1, is that going to be plus x? Good. And so in this case, we're along this line, which is this line, right? And we're trying to figure out the direction that the solutions are traveling there. And so again, this is going to be a parabola that goes up in this case. 0 and 1. So if we're less than 0, it's negative. Oops, got that wrong. Negative in between, positive and positive. So that means we're going to be traveling to the right if x is less than 0. Then between 0 and 1 we'll be traveling to the left, and then traveling to the right if x is bigger than 1. Good. So here's my break. That's where x is equal to 1. And so we said that between 0 and 1 we'll be traveling to the right, right? along this curve. Okay, if x is less than 0, we'll be traveling left, and then that's greater than 1, and then for these values of x in here, we'll be traveling left, and then for these up here, we would be traveling right. Good. And so now we can try to do a little bit of analysis here on our other solutions. Where are our solutions going? Alright, so let's go through that one again. I'll use red just to emphasize what these are going to be here. So if y is less than 0, we should be going up. And then for y between 0 and 1, we should be going down. And then for y greater than 1, we should be going up. Good. That makes more sense. I think we've got it all now. And so this region is going to make more sense. Now what's happening if you're in region C, or in the book is calling this region C right here. Yeah, you're moving out of the region, right? And so you're not sticking around. But if you get in this region, it looks like all solutions are heading towards this region. And so it looks like once you're there, you're probably going to end up at this equilibrium solution. And so we've got these two ends here, right? This end and this end, where all solutions are moving towards the equilibria. And then these out here, it is possible for us to avoid these regions, but it looks like we will get trapped in one or the other, doesn't it? Yeah, so this is the method of Nullclines, and I'm going to pause for a second and I'll pull up the direction field plotter that we have online, and we can take a look at see if we're pretty close to being accurate there. Okay, I brought us out of pause just to show you where the link is. This is the link I'm talking about from Friday, so if you click on that, you'll bring this page up, and then if you go to System, that's where we want to be. And then for here, we'll just go ahead and I'll pause again for a minute while I type in the direction field. Good. Okay, so here's the graph. Just a couple notes when you're doing the direction field, right? Don't forget to put in the multiplication signs there, the asterisks. Otherwise it might give you something weird, or it'll give you an error. Yeah, we could choose different algorithms here, but that's fine. I just wanted to plot a few sample solution curves because we were saying that solutions were doing a certain behavior. We wanted to double check to see if that was happening. Good, so you see what's happening here. So what are we seeing here? I think we're seeing a sink. Is that a sink? That's a saddle. That's a source. Oops. And that is a sink, right? Yep. Good. So 2 sinks, a saddle, and a source. Very good. Good, so in the next video we're going to just do another example from start to finish.